Today we shall be discussing the second chapter of electric circuits, which is the basic laws. Okay. Every topic in this basic laws is important and questions are asked every year. So you better have a thorough practice of questions regarding these topics. Okay. So let's get started. We are having the pretty basic thing is Ohm's law, which is familiar to everybody, and we need to follow these current directions. This is where student makes more mistakes. Okay, keep in mind this particular diagram and this particular convention. Now, depending upon the value of resistance, which could be 0 or infinite, a circuit could be short circuit or open circuit. In short circuit we have voltage equals to 0, and in open circuit we have current equals to 0. Let's talk about power absorbed by resistance. P equals to VI or V square by R or I square R, whatever suits your interest or whatever is the demand of the question. Resistance always absorbs power. Let's talk about branch. Any single element or a group of element in a circuit could be referred to as a branch, and every branch has a particular current. Let's talk about KCL. KCL follows the law of conservation of charge, and it states that at any node the sum of current equals to 0. The convention to be followed is for incoming current we are going for plus, and for outgoing current we are going for minus. Let's talk about KVL, which follows the law of conservation of energy and states that in a closed path sum of voltage equals to 0. Now this is the particular convention you need to keep in mind, and I would request you to write it somewhere else so you don't make mistakes while doing numericals. Okay, this is where students make most mistakes. Okay, so keep in mind this particular diagram, okay, and this particular convention. Now let's talk about voltage division, and this thing happens in series resistance combinations only. And if we have to find resistance across, if we have to find voltage across nth resistance, then we have this particular formula. Okay, and Vs is the supply voltage. Now we are following current division, which is only applicable in parallel resistance combination. And if we have to find current through through nth resistance, then we have this particular formula where Is is the supply current. An important thing to keep in mind is that equivalent resistance is generally smaller than the smallest resistance in a parallel combination. Let's talk about source transformation. Ideal voltage source has 0 internal resistance, and ideal current source has infinite internal resistance. This is the conventions, and these are the things to be followed while transformation. From voltage source to current source we have this thing in mind. Okay, you have to keep this in mind and the entire diagram in mind. Okay, and this as well. And this is not applicable for dependable sources. Keep in mind this is not applicable for source transformation, is not applicable for dependable sources. Now we have sources in series or parallel, and these are the conventions you have to keep in mind. For sources in series we having plus because they are having same polarity. Opposite polarity would lead to subtraction. When they are in parallel they are equal. Same goes for current. When they are in parallel, same polarity we are adding them, opposite polarity we are subtracting them. When they are in series they are equal. Then we have series, parallel voltage and current sources, and these things are applicable for ideal sources only. Okay, if it is mentioned it is an ideal source only, then you perform this transformation for easier calculations. Okay, if a voltage and current sources are in series, you can take into account the current source only, and if voltage and current source are in parallel, you can take the voltage source only. Okay, let's talk about star to delta transformation. Okay, here we are having R1, R2 and R3, and RA and RB and IC over here. So, okay, and these are the things to be followed. It is pretty basic, pretty easy. 1 or 2 questions if you have practice on, you can get it very easily. Okay, these are the questions easy. Okay, there is nothing tough on that, and you can score pretty easily when it comes to network. Now we are doing just the opposite thing. We are now transforming delta into star, and we have R1, 2, 3. 1, 2, 3 resistances over here, and our ABC resistances over here. Okay, and this is the formula to be followed. Then we have certain things in mind that KVL and KCL are applicable on lumped circuits only and not distributed. Ohm's law is followed by both lumped and distributed circuits. KVL and KCL are followed by lumped, linear, non-linear, time variant, time invariant, active and passive elements. Okay, This is an important thing to remember. Okay, now we have network theory for less than 1 megahertz frequency of the circuit, and we have field theory for greater than 1 megahertz frequency of the circuit. So this is all for basic laws. Okay.